Okay, this is the pre-quiz. Okay. Have I made any mistakes? Is this the right circuit?
Yeah.
Are we good? So there's lots of places we can start. Actually, there's two places we can start, right? To begin with this. My favorite place to start would be right here. This is clearly, what is that? Those are series, right? And that's clearly a 12, right? I don't want to get that wrong, right? Okay. And then the 12, if that's one resistor, and the 9 are connected in parallel, right? So that's going to be my first stored value. That guy is 1 over 12. So 1 divided by parenthesis, 1 divided by 12 plus 1 divided by 9. So that's a common everyday 5.1429. I'm going to store that in A. So that's my value A. Am I right so far? You guys get something like that?
Yeah.
Yeah, stop me if I get it wrong. And then I think we can do these guys here, right? These guys are definitely parallel, right? So that's going to be 1 divided by parenthesis, 1 divided by 11 plus 1 divided by 13. And I'm going to store that in B. And this is 5.9583 repeating. That's also B for me, right? And then I think the next thing to do is to make these guys in series. Like that. So that's just 3 plus that. 3 plus B. I'm going to store that in C. So C is, that's just 8.9583, right? Repeating. And then C and 15 are connected how? They're parallel, right? Because the rule is that if both ends are connected, right? So this end here is connected to that end. This end's connected to that end. So it's definitely parallel. So this is going to be my next one, right? I'm going to call it D. So use up all the letters of the alphabet, right? So that's going to be 1 over divided by 1 divided by C, right? Plus 1 divided by 15, right? And let's store that in, well, I guess we're on D. So this is 5.6087, okay, or D for me. Are we good so far? Do you guys get those values? So now it's what kind of circuit? We've got a battery of 5.1429 or whatever, right? A 5.6087 and a 4. What is that? What kind of circuit is that? Yeah, we don't joke about that kind, right? We're serious about those. Right? So it's like doot, 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 doot. Right? So that's the one current there. The one current is, and this is what A1 is going to read, right? Is 45 divided by A, this guy here, right? Plus D plus 4, right? A is 5.1429. D is 5.6087. I guess I'm going to store this in E. Okay. 45 divided by alpha A plus alpha D plus 4. And this is definitely the end of the line. If we don't get the value that we're supposed to get here, 3.0505. Is that what the answer is supposed to be for A1? 3.05 amps. So it looks like we're on the right track. Yes. Okay. And now we can figure out a bunch of things. Okay. We can find out this voltage right here. Notice that this voltmeter is across the resistor A. It's from here to here. It's not across the 9 or the 12 or the 5 or the 7 for that matter, right? It's from this edge of this whole agglomerated sort of resistor thing to the other side of it, right? I could have attached it here and here. It would be the same exact place, right? So V2 is I times R. So it's this current here, 3.0505, or in my case the letter E, right? Times this resistance, 5.1429, which for me is the letter A. So I just have to go E, yay. It's like, yeah. Okay, that's not that funny, but I thought it was sort of funny. Okay. And I'm going to store that in, I guess I'm on F. Okay. So let's go alpha E times alpha A, storage F. I'm going to use up all the letters of the alphabet. 15.688, is that right? 6884 volts, and that's stored in F. And is that the right answer? Do we have? Yeah, V2 is 15.7. So that looks like a good. Yeah. Okay. Then it says find the current through the 7 ohm resistor. Wouldn't this be a good time to find the current through the 7 ohm resistor? Right? So the current through the 7 ohm resistor is going to be this voltage. That's the voltage that drives the current through the 7 ohm resistor. Yeah? I'm not going to redraw the circuit with that. I'm just saying we can ignore the rest of the circuit. We know the potential from here to here is 15.6884, right? And if I divide that by 12, I'm going to get the current through this part of the circuit. If I divide by 9, I'll get the current through that part of the circuit. The sum of those two currents will add up to this current, right? Although I don't think they ever ask us about that current. So this current here through the 7, okay, this current, okay, is just V over R. So it's going to be 15.6884. divided by the total resistance in that path is 12. So I just take this, divide by 12. I get 1.30736 amps. Is that the right answer? Yes, there we go. So we picked off that one, and it doesn't ask anything else in this part of the circuit, right? So we're kind of done with that part of the circuit. Now let's find V1, okay? So to find V1 here, V1 is going to be equal to I times R. Remember, we're now back in the big circuit here. There's this current going through it. There's this resistance from here to here. It's the whole resistance, right? It's not just this side. It's not the 15. It's not the 3. It's this whole thing all put together has this current going through it, right? So I'm going to take this current times that resistance, right? And this is somewhat satisfying for me. This is letter E, and this is D, and that spells ed, right? Which I think is better than yeah, you know? Okay, where was that? There it is, right? Okay, so this is equal to 3.0505 amps times 5.6087 ohms. Amps